Welcome to the Data Center Knowledge webinar series. Today's webinar is titled Why 1% Efficiency Matters. I'm Bill Clayman, featured contributor for Data Center Knowledge. Thank you for joining us for today's webinar. And today's focus is why stakeholders involved in UPS data center projects should employ a TCO model throughout the entire process and always look for ways of bringing together the seemingly divergent goals of purchasing and operational teams. Now, our presenters today are Brad Thrash, the Global Product Manager for GE, and Harry Hanlon, the Director of Critical Power Applications at GE. Now, today's webinar is sponsored by GE Critical Power. GE's Critical Power division creates, designs, and deploys some of the world's most innovative, powerful power and efficiency solutions. Tackling the industry's most challenging demands, GE Critical Power delivers automated switch transfers, critical power distribution, advanced DC power systems, turnkey data centers, containers, intelligent, uninterruptible power supplies, both 3 and single phase. GE's critical power products achieve power availability of up to 99.999%, the equivalent of just a few seconds of downtime per year, by providing immediate UPS power backup and power switching solutions while reducing the disturbances on the system. Now, before we begin, if you have any questions at all, please type them into the questions box that you should see either on the left or the bottom side of your screen. If the box doesn't appear, make sure you click the red Q&A button at the bottom of your screen. All questions will be directed to our speaker during or at the end of the presentation. We often get feedback that the Q&A sessions are extremely valuable part of the education process, so you'll definitely want to stick around for that. Now, with that, let's begin by introducing our speakers for today. We've got Brad Thrash and Harry Hanlon. Brad is the product manager for GE's Critical Power business and is responsible for AC Power Systems, the product line globally. In more than 25 years of experience at GE, Brad has held leadership roles in various businesses, including GE's power quality and power generation businesses. In these roles, he focused on application engineering, service engineering, sales, and product management. Brad holds a Bachelor's of Science in Mechanical Engineering and is a licensed professional engineer. He's a member of the Institute of Electrical and Electronics Engineers, IEEE, and the American Society for Mechanical Engineers, ASME. Brad is also on the Power Sub-Work Group on the Green Grid. Harry Hanlon, our other speaker for today, holds a Bachelor's of Science in Electrical Engineering and has been with GE for over 8 years. He's the Technical Committee Chair of the Green Grid and helps colleagues understand some of the most innovative modern power requirements. At GE, Harry directly interfaces with customers, consultants, and designers around architecting dynamic, critical power systems. With that, Brad and Harry, welcome to the Data Center Knowledge webinar series.
Thanks, Bill, and welcome to today's session. The topic today is Data Center UPS Systems and why 1% efficiency matters. Joining me today is Harry Hanlon. We work very close together both at GE and also in the Green Grid, and we'll be both co-presenting. We'll take about 25, 30 minutes to go through these slides, and then at the end we'll open it up for the Q&A. So the key question or topic that we're trying to address for data center owners and operators is really 3 key themes. One is why efficiency gains as small as 1% really matter and what impact it has on the total cost of ownership within a data center. And we'll actually walk through a case study of a 10-megawatt data center and why a TCO model should be an important part of the equipment selection process. And then we'll wrap this up with some discussions about how to consider TCO in combining CapEx and OpEx in the decision process with equipment. And one key element of this is that with total cost of ownership, while it's fairly well understood in data centers, it's talked about quite a bit, often that metric is not used in the final decision making as far as purchasing and selecting equipment. And if that decision is made correctly, it could save millions of dollars of operating expense or total cost of ownership over the life of the equipment. And this is a key part of what we'll be discussing today. Most of you know that in data centers today, there is a lot of focus on energy efficiency. With the cloud compute model taking hold in the industry, there's expectations that the energy consumption in data centers in the future could be 10 to 12 times what it is today in terms of these cloud compute data centers. There's been a great deal of regulation in both government and non-government organizations in terms of trying to put a spotlight on efficiency. We've seen it through the EPA, through the Energy Star program. We've seen it with the Department of Energy Also, the Green Grid organization has been very prominent in this role with the PUE metric to help guide the data center industry on the PUE metric for measuring the infrastructure efficiency. Another key part of this is we consume energy in the data center. It gets thrown off as heat, and we have to cool data centers. We've got to take the heat out of the data center with cooling. And all of this puts a spotlight on how energy efficiency impacts data centers and what the impact of that will be on TCO. So TCO, just simply defined, it is total cost of ownership. And what we're doing with TCO is just you're taking the CapEx expenditure of the equipment and you're combining it with the operating expenditure of the equipment over the life of that equipment. Usually this is used when the equipment is over a long-term period of time, say 5-10 years. And also, it also looks at combining the purchase price with the long-term cost of the equipment, and also concludes that the lowest purchase price always isn't the best decision. And if TCO is not used in that decision, it could cost, again, millions of dollars. So how does this translate to a data center operator when you're trying to make a decision on a UPS? It really translates into a couple of key factors. On the CapEx side, it's just the cost of the UPS itself. It's the equipment cost and the installation cost of the equipment. Combining that with the operating expense, and operating expense includes maintenance, battery replacements, fan replacements, cap replacements, all that maintenance cost has to be considered. And then the energy cost. This is the energy cost in terms of the UPS since it consumes energy. And the UPS energy loss is converted to heat, and that heat has to be removed with cooling energy. And that has to be totaled up in terms of kilowatt hours and total cost of the energy consumption. And all that gets added up, and that drives the UPS total cost of ownership. So with that, I'm going to turn it over to Harry now. He's going to walk you through a real example in terms of, as consumers, that we deal with in terms of automobiles with an analogy. Harry?
Thanks, Brad. This is a TCO calculator that's available off the internet for determining the total cost of ownership for an automobile purchase. And this includes all the costs related to the automobile. You get the total price, you've got sales tax, licenses, insurance, any kind of extended warranty, all the way through. And you'll notice circled the only difference between the two vehicles for this example is the vehicle's estimated miles per gallon. One is 18 and the other is 28. Everything else is the same. How does that one variable impact the total TCO model? Next slide. So if you look at this, it really has a fairly substantial impact in that there's a difference in operating costs of about $6,000 over the 5-year life of the period. And if you look at that, that actually gets down for about $100 a month as far as your monthly cost of owning that automobile. So that's interesting in that the total cost of ownership are both almost twice the original purchase price of the car, which was $25,000. And the only difference is the fuel price. And we use $3.19 a gallon, which is what the fuel prices are where I'm from in Alabama. But, the difference is approximately about 25% of the purchase price, or about $6,300. So, next slide. So what happens if gas was 3 times today's price? Makes a huge difference in the TCO model. And this may seem a little far-fetched. Nobody's expecting gas to go up to, $9 or $10 a gallon. But if it did, the fuel costs for the 18 mile per hour over the period increase to over $50,000, or over twice the purchase price. For the higher efficiency vehicle, they increase another $34,000 to over $34,000, which is $10,000 higher than the purchase price. So you're going to pay more for fuel than you pay for the purchase price of the automobile. And while, again, this seems a little bit strange and not something we'd see in the real world in the U.S., But if you look at the data center analogy with a UPS with a 92% efficiency, the cost to operate that UPS, just the power, the losses, and the cooling required to pull those losses out of the data center can exceed the purchase price of the module in as little as 3 years. So it is a huge difference in impact that efficiency makes on the UPS. Next slide. So if we applied that to a 10-megawatt data center with a 10-year life, 10 cents a kilowatt hour, and assume the UPSs are at 50% load, you can see the difference. And here we've looked at CapEx and energy costs. And you can see the difference that it makes going from 93% to 94% to 96.5% efficiency. And there are different types of UPSs out there and topologies that will give you different efficiencies. There are some operating modes that you could get up to 99% and save even more. And with that, I'll turn it back over to Brad.
Thanks, Harry. And what I'd like to do now is dive into the TCO variables a little bit more. And there are some variables in a TCO evaluation that are controlled by the site, and there are other variables that are really controlled by the product. It's important to understand these distinctions and what the impact is on TCO. So site variables would include first, asset life. This is just how long will the asset be there. In the case of a data center, will it be there 5 years, 10 years, 15 or 20 years? And that's an important factor in terms of how to do the TCO. And obviously, if an asset life is only 1 year, energy efficiency doesn't matter as much. If the asset life is 5 or 10 years or longer, then the operating expense or the energy consumption matters a lot more. The other variable is UPS and load of the UPS. And so the analogy here would be, is to Harry's point, if you look at a 10-megawatt data center where the load is very, very high, the impact is very, very great because the loading, if the load is much lower, say if it's partly loaded at very, very low loads, then it won't matter. Then efficiency will not matter near as much. The other factor, Harry brought this up, the analogy was related to gas price, but the same thing applies to the cost of electricity. If cost of electricity is very, very low, then the impact efficiency may not be as impactful. If cost of electricity is higher, it'll have a bigger impact on the TCO evaluation. And the other variable here is the future price of electricity. What will happen? I think most of us know that electricity prices tend not to be going down. They tend to be going up over time. And so that has to be considered as well. And then last is what we call cooling factor. And this is just, as we talked about earlier, UPSs generate heat. That heat needs to be removed from the equipment room. And the cooling factor is just how efficient the cooling system is in removing that heat from the room. That has to be factored into the TCO model. And a good proxy for this is PUE. If you think about the PUE metric that most of us know, that's a good proxy to understand how effective is the cooling system to remove heat from the room. So a PUE of a 2.0 would not be particularly efficient by today's standards, but often many data centers are operated at a level of 2.0 for PUE. And if you operate at 1.1 PUE, you have a probably very, very efficient cooling system. So those are all what we call site variables that are controlled depending upon where the site's located. Another factor on the cooling is obviously location. Obviously, if you're in a what we call free cooling zone where low temperature, low humidity can be used, so you don't have to run a chiller plant to remove heat, that also helps in that cooling factor. The product variables that impact TCO is the purchase price, just how much does equipment cost and how much does it cost to install. The UPS efficiency is a key driver. We'll talk a little bit more about that, but there's different technologies in terms of driving UPS efficiencies, and also at what load point or what operating load are you operating. Then the cost of the maintenance, ongoing maintenance for servicing the equipment, and then the battery replacement and other component replacement like caps and fans that must be replaced over time have to be considered as part of that TCO variables. Just one comment on the, I'm going to go back to the previous slide. One comment on this I did not highlight, but I want to comment on it, is that with the analysis that we're doing here, we call it a straight line evaluation. There is, in some TCO models, you can use what's called a net present value. That's where you actually look at time cost of money, cost of capital, escalation rates. And for simplicity, for the evaluations we used in today's case studies, we used just the straight linear extrapolation of cost over time. but you can use a net present value calculation to make it a little more precise, and that's just where you factor in the time use of money in that evaluation. Now, this is just a little more detailed evaluation of a data center. This is actually a 4-megawatt data center. This is a 10-year life, so the assumption here is this is a data center that will be in operation at least 10 years. The cost of electricity for this evaluation was 10 cents per kilowatt hour. And what was compared here is 4 different UPSs in terms of their efficiency levels. And on the left-hand side, you see the y-axis. This is actually the UPS total cost of ownership in thousands of dollars. And then on the bottom, the x-axis just shows the different UPS efficiencies that were evaluated. So the first bar shows a UPS with a 92% efficiency level. And if you look, there's 3 sub-bars to this. There's the cost of the equipment, there's the maintenance cost, and there's the energy consumption cost. And by far, the cost of energy in that scenario is much greater than the cost of the equipment or the maintenance costs. And if you keep moving to the right, then we looked at a 93.5% efficient UPS, and you can see we save almost $1 million in terms of TCO just by making that one change in efficiency by going to 93.5% efficient. And if you keep going to the right one step further, you see a 96.5% efficient UPS, and as you can see, the TCO keeps getting lower. And in the far right is a 99% efficient. This is actually an eco mode, operating mode, where the efficiency is very, very low and the cost of energy consumption is very, very low. And the TCO really drops to, in this case, somewhere around $2 million, which is insignificant relative to the cost of the equipment. So what it means here is that if you start with a very inefficient UPS, like 92, 93%, then the energy consumption dominates the TCO model. If you keep going to the right and you get up to 99%, where efficiency is very, very high and the cost of energy consumption is very, very low, then the energy consumption becomes a less part of the TCO. And so this is a key learning in terms of what energy consumption, energy efficiency does to this TCO model. What's constant throughout all of these is the initial cost, and the maintenance cost is fairly constant. Slight differences in price or installation costs or slight differences in maintenance costs really don't drive the outcome of the TCO evaluation. So that's a key learning from this evaluation that was performed. And with that, what I'll do is I'm going to turn it over back to Harry, and then he will actually talk through how to think about when you're making a decision and evaluation, how to consider TCO in that evaluation process. Oh, before I do that, I do want to comment. One thing I did not comment on here on this chart. What drives some of these differences in efficiency is a question we often get. And if you look at the left-hand side, a 92% efficient UPS, this is a traditional efficiency of a transformer-based UPS, typically with input transformers, output transformers, what we call a 2-level IGBT technology, which was fairly common 10 years ago. And that was fairly common 10 years ago in that range. And you go to the 96.5% double conversion. This requires more advanced technology, 3-level topologies on the IGBTs to get double conversion efficiency up to 96.5%. And the far right-hand side is our technology is called eBoost, but it's multi-mode or eco mode, where you actually operate the UPS in the bypass mode. But those are some of the key technologies that drive these efficiencies in terms of these differences. So with that, what I'm going to do, I'm going to turn it back over to Harry, and he will help this audience think through how to consider TCO as you make equipment selection decisions. Harry, back to you.
Thanks, Brad. And what we really see a lot in the data center market is that a TCO analysis is usually done in the design stage. And they look at it to say, okay, which design am I going to go with? What topology am I going to use for the design of my data center? What type of cooling system might I use? What's the payback for one type of cooling versus another? And the TCO process is well understood and well implemented in that particular time. But then you prepare the RFQ with the specifications, solicit bids, and as long as the UPS or other piece of equipment that you're evaluating for a total cost of ownership, you evaluate the bids, but the TCO usually doesn't get evaluated at that point. Any differences in efficiency which impact the operating costs are not considered. And this is typical because usually it's a corporate real estate department or a project manager is tasked with ensuring that the data center construction project is finished on time and under budget. And in many cases, their client, the future data center IT or facilities managers, may not even have the utility bill in his budget either. So the project specification is written to ensure multiple suppliers that can meet a specified efficiency with no credit given to any products that exceed the minimum efficiency requirements. So you can see the flow chart's pretty straightforward. Solicit bids, evaluate, select based on price and delivery, and issue a PO. Next slide. What we're starting to see some companies do is to basically use similar decision process, except when they solicit the bids, they ask for the pertinent information on the TCO. Some of the items that Brad pointed out earlier as far as the product items. What's the efficiency at the anticipated load point? Things like that are requested with the submittal so that you can then plug those variables into the TCO model and evaluate the bids along with TCO. And then you select the supplier, issue the PO, and you actually save OpEx dollars when that decision is made for an overall cost or total cost of ownership rather than just initial cost. Now, this does require a cultural change in a lot of organizations because, as stated earlier, the person responsible for the purchasing decision, usually the total cost of ownership is not his metric that he needs to meet, and he doesn't pay the power bill, and he probably doesn't even know who pays the power bill. So he is not looking to try to maximize that part. So we think this is a really good way to look at evaluating bids and getting the lowest total cost for a UPS system. And as Brad showed on some of the earlier charts, you can save millions of dollars. So, Brad, back to you.
Thanks, Harry. And this last chart we're sharing with the team here is a Core Space. They're a co-location provider based in Dallas, Texas, and they had a 30,000 or have a 30,000 square foot facility in Dallas, and they were looking to replace their existing UPS, and they were trying to make an informed decision about the right decision process. And they decided to go with a GE three-phase UPS, actually using our eBoost technology because of the high efficiency of 99% eBoost. And with that, they saved about $88,000 per year. And what that does for them in terms of their business model, it helps save energy costs, but also gives them a better PUE metric and makes it more attractive for their customers to attract customers to their data center. So this is a real example where CoreSpace used the TCO evaluation to see how much it would save them and use that to translate that to their business model. So with that, I think that's all we had as far as a formal presentation. And what we can do is turn it back over to Bill, and we'll try to answer any questions or answers you might have.
Fantastic. Thank you, Brad and Harry. Wow, we are getting a lot of questions coming in. I'm going to try and cover as many of these as I can. Fortunately, we do have some time here. Like I said, we do have questions coming in for specifically Brad and Harry. If you have any more questions, please, by all means, at the bottom of your screen, you're going to see a Q&A button. Go ahead and punch those in there. We've got some time. We'll go ahead and answer those. Brad and Harry, as you can imagine, you're going to get some questions around TCO, valuations, and whatnot. I'm just taking a look at some of these questions here. Let's start with this one. How can TCO valuations identify barriers to cutting long-term costs, and how do you actually conduct those kinds of valuations?
Yeah, maybe I'll start first and Harry can jump in. But basically, what TCO forces, it really encourages teams to evaluate the initial cost of the equipment and to ask the important questions about the efficiency of the equipment, how long will the asset be in operation, what will the load levels be. So it asks some very fundamental questions that should be part of any project decision-making process. And by doing this, it really gives an overall example of how this asset will cost the business, the company making the purchase over the life of the asset. And it really ties together the upfront project teams that Harry talked about that often are tied to, their metrics are often tied to project costs or schedules, with the operating teams who eventually have to operate the asset and pay the power bill. And it really puts those teams together, working together to try to solve the problem together.
Yeah, Brad, just to add to that, what we're seeing in the marketplace today is not just a focus on reliability and efficiency. We're actually hearing some new words out there from managers and management running data centers. Words like, how do I keep my data center competitive 5 years from now? I build a new data center. How are those costs going to be contained? So we're seeing some of the higher ups in certain organizations, people like the CFO, maybe the chief IT officer, are all asking those questions. How do I control my budget for my IT spend? What am I going to do as far as operational costs? And if power prices go up or if my loading goes up, my operational costs are going to go up. How do I contain them and keep them down? TCO is a great way to look at what your data center is going to cost you year one, and you can model different scenarios off of that. So it really gives you a good way to control costs by making intelligent purchasing decisions.
Perfect. We've got some more questions here. I'm going to try, Brad and Harry, go ahead and follow me on this, and the rest of the audience as well. I'm going to try and group a few of these questions together. And again, if you got some more coming in, by all means, go ahead and put them in the Q&A section. Many organizations are looking at ways to power their entire environment. I mean, you've got companies looking for new, basically these shops are looking for new types of power plants. So kind of a three-part question here. What are some efficiency advancements that you're seeing around DC power systems, and specifically in the UPS arena modules? Can you touch a little bit on price variance behind efficiency and how that impacts TCO?
Yeah, I'll take. I think I understand. The question I heard was, what are some of the future efficiency advancements we see in data centers? Is that what the question was asking?
Yeah, data centers and power systems specifically, right.
Gotcha.
And how price variance plays into that.
Right. Well, and I did hear the DC. So there's actually, UPS systems today are what we call AC systems. There's also other ways to solve this power quality to data centers using DC power. And actually, we're involved in both sides of that. We do AC or DC, and we can provide both solutions. Both are being driven toward higher efficiencies. They have similar efficiencies today between AC and DC. DC might have a 1 or 2% advantage in terms of efficiency, but it's not a big difference since both of them have advanced in terms of their efficiency levels. The big driver we see is, as far as the power conversion technology, is if it's running in double conversion mode, we do see 3-level topologies being used as far as converting power. The E-Boost technology or multi-mode technology or eco-mode technology is also being deployed. Many end users don't deploy eco-mode in AC UPS because of the historical concerns about reliability, but our experience has been that the reliability of eco-mode has been equal to or double conversion, but that's been a trend that we're seeing adoption of that. And as far as the price variation, there's obviously some differences in pricing maybe between these, but in terms of the overall TCO, pricing difference between UPS modules is not a big factor in terms of the driver in that decision process. And what we see with the UPS module cost levels today is very, very competitive relative to, say, 10 years ago in terms of dollars per kW. Very, very competitive dollars per kW in terms of that initial cost.
Yeah, and I think, Brad, what may have driven some of the question is that in all our examples, we use the same purchase price regardless of the technology or the efficiency of the UPS. And that was mainly to get a baseline case, just like the automobile. We had two automobiles that cost exactly the same. You know, in the real world, that's not going to happen. You are going to see some slight variations in price or in costs for maintenance items, other things. But typically, as Brad said, they're going to be very small variations that aren't going to affect the overall TCO. And rather than show you examples where we altered a lot of different variables, we just altered the one variable. In the car, it was miles per gallon. In the UPS, it was the efficiency.
Perfect. Well, I'm glad I got this question coming in here, and it's really revolving around disaster recovery and business continuity. So Ken asked this one. So mean time between failure is still a primary important factor, and he's specifically asking about eBoost. How does eBoost mode directly affect reliability?
Yeah, I mean, eBoost, that's a GE term for what we call a multi-mode UPS. And what a multi-mode UPS is doing, it's a double conversion UPS. And with the advanced technologies available today, we can operate these UPSs so that the utility power bypasses the rectifier inverter section. It goes to the static switch, and we let that clean utility power pass through directly to the load, and we switch back to the inverter only when we see a power quality disturbance. And the key to this is to be able to switch back to the inverter within fast enough duration to make sure that the downstream loads aren't impacted. And the technology today exists to allow this operating mode to be as reliable or more reliable than double conversion, because now you've got two paths to get power to the load. And so our experience has been it's been equal, as reliable or more reliable than even double conversion.
Perfect. Here's another really interesting question around specifically engaging the decision-making process when it comes to looking at the energy aspect of your organization. So how are successful organizations engaging the entire decision-making or decision-maker value chain in their energy company, so like CEOs, facilities, IT, and how do they calculate the simple payback that's required to drive a TCO?
Yeah, maybe Harry from our team deals quite a bit with end customers and consultants and others. So maybe Harry, do you want to try to take that one?
Sure, thanks, Brad. We see a lot of different ways of how TCOs are used in organizations and what's driving them. We see that they're being used mainly when the organizational structure is based on a cross-functional team where you'll have people from operations involved, you'll have people from facilities, IT, and others involved in the overall decision-making process. We've dealt with several clients that have done that, and some have had very, very sophisticated TCO models where they would vary the load over time to model what their anticipated loading would be as the data center grew and the build-out was complete. But as far as the overall payback, that usually varies from organization to organization based on their corporate culture and corporate values. You know, you've got some folks out there that say, gee, if it doesn't have a 2-year payback, I'm not going to pay any extra dollars for it. Other folks said, hey, if it's a 3 to 5 year payback, you know, let's look at it. In most cases, doing a TCO on a long-term asset like the critical power system of a data center, you're going to be looking at a 10 to 15 year cycle. 15 years really good because that's typically the normal life or service life of a UPS. The design life of a UPS is much longer, but that's the service life, and it also fits in real well with your number of battery replacements that you do depending on your battery technology. For instance, a valve-regulated product normally in a UPS application will last about 5 years, so you can do 2 battery replacements on your valve-regulated product, one at 5 years, one at 10 years, and it takes you to 15-year life. If you're only doing a 10-year TCO, you only have 1 battery replacement. If you're looking at a flooded cell product, typically that's about an 8-year life. So again, then you'd be looking at about 15 years, 16 years being end of life. So it really matches up well with the battery technology, where the UPS is, and looking at the total system as far as the life of a data center. And that has a lot of impact on how the organization looks at it. So those are some of the variables that really come from within the organization.
And I just want to add to this a little bit in terms of, this data center industry is beginning to mature, and we're seeing some level of consolidation in terms of companies that do this every day. And whether it's from the cloud compute companies or Fortune 500 companies or co-location companies that are becoming proficient, and these are the companies that we see as thought leaders in terms of looking at TCO and making these informed decisions about OpEx and CapEx and combining those together. Not everyone's doing this, but we see the leaders in the data center industry net right now really driving this TCO evaluation.
And that's an excellent point around cloud computing. We see these kinds of modern data centers really impacting how organizations are trying to align what they're doing with business and technology, and how those two factors are absolutely critical in terms of forming this new sort of business paradigm. To outcompute means to outcompete. And a big part of that revolves around really uptime. And so we've got a couple more questions here. So the modern data center is absolutely a critical component for really any modern organization and business. So with that in mind, uptime is absolutely critical. I mentioned that one of the things that GE Critical Power is doing is absolutely focusing on uptime, resulting in just a few seconds of being down any time per year. So this is sort of looking ahead in terms of looking at UPS systems and power plants. What is GE doing to create these great next-generation uninterruptible power supplies? And can you touch on use cases and differences between like single and three-phase units and where you see those being deployed?
Yeah, maybe I'll start, and Harry should jump in as well. One of the elements that the data center industry is going through is trying to evaluate what level of reliability is required for their application, and then trying to use that to find the level of reliability in terms of what's the install cost of putting that equipment in. And what you'll find today is there is this effort to make sure we understand what those criteria are in terms of reliability and define the system architecture required to meet that. So we're seeing some data centers today that do not need ultimate, perfect reliability. They have applications that can handle some interruptions, so they may not spend as much on multiple redundant UPSs, and they may do something different from a system architecture versus other applications where, whether it's video streaming or e-commerce where, no downtime's allowed, where they put in more infrastructure. So we're seeing a lot more thought process put behind, what is the IT application, the data center application, what level of reliability is required, and then how much infrastructure will I put in terms of a system architecture to achieve that. And we do see some shifts in terms of thought process on trying to achieve that. In the case of co-location companies, they often have in their business models what are called service level agreements to their clients. And they provide a guarantee of uptime of the infrastructure, including power. And if that uptime is not achieved, they often have to give back some of their revenue stream back to their clients. So we see a lot of intelligence being built into the data center model, both technically and commercially, in terms of what level of reliability is required and how much cost should be considered to achieve that level of reliability.
Yeah, and I think we're seeing the data center industry evolve to the point to where we're seeing a lot of business principles driving some of the decisions that data centers are making. We've got several clients that are looking at their portfolio of IT loads and deciding which is the best option for them. Do I go out and build a super state-of-the-art data center and put everything in there and it costs me X, or should I take some really critical applications, keep them in my data center, take some less critical, put them in the cloud, take some others that are maybe in between and go with a co-location model and have a mixed portfolio of different IT solutions for my compute needs. And we're seeing a lot of organizations use a TCO model to come to those decisions to say, okay, this is how much it cost me to build this much. If I built more, it would cost this much. And a lot of times that evaluation is looked at as far as dollars a kW for your IT load. And that is driving a lot of decisions, and there's a lot more thought and a lot more business principles being applied to what do I do with my IT loads today, and what's the most competitive way that I can do it. Cost has really become a factor.
Yeah. And just to add to that, so the example would be that for an ultra-reliable mission-critical facility, we use a term called system plus system. This is where you have a side A of UPS systems and a side B of UPS systems. They're completely redundant with independent switchgear and diesel gens. And we do this so that if one whole side goes down, the other side can take the load. And that is the ultimate in terms of system reliability. The issue with that approach is that now you've got, and the analogy is like a jet engine. It's like jet engines on a jet plane. You've got 2 engines or 4 engines, and any engine can fail and the other can carry the load. In that scenario, the jet engine's always operating below 50% load, 45% load. That means your utilization level of the asset is relatively low. We have the same challenge with critical power infrastructure, especially UPS systems. When we go to these system plus system architectures to achieve high reliability, what we end up with is UPS systems operating at 45% load on each side. So you have to put a lot of these in. A lot of them, UPS companies love this because, you have to buy a lot more UPSs. But we think there's going to be some changes in system architectures to reevaluate that. Is this the best way to solve this problem? How do we achieve high reliability with different system architectures? So moving forward, I think we're going to see a lot of effort on the system architecture side to optimize this, to make those trade-offs better informed decisions.
Perfect. And you know what? We've got another question coming in here that kind of piggybacks off this conversation in terms of looking at these new advancements and these new kinds of efficiencies. How is this going to impact the future TCO model and future evaluations and really the future efficiency model around things like the data center, power consumption, and even the cloud?
Wow, Harry, that's a big one. That sounds like a green grid question.
Yeah, I think there are a lot of questions out there in the industry around cloud computing, around infrastructures for cloud computing, and about what model cloud computing should have, and how does that relate to an infrastructure. I know from our viewpoint, we see a lot of different customers coming up with completely different answers to that. On one end of the spectrum, we'll see some data centers that have multiple data centers, and they're close enough to where latency is not a large problem, and they'll actually move loads around and have a less resilient infrastructure. Others, for instance, a co-location company that offers cloud services realizes that you've really got to irritate a customer for him to take his IT equipment out of your co-location data center, go put it to somebody else. That's a very painful experience for the end user to do that. So you have really got to make him mad where that's going to happen. If you're offering a cloud product, he just goes from one cloud to another almost overnight. So you really can't afford any disruptions, and they're going to much more robust infrastructures. And again, it's based upon what they feel like the business need is. In the case of a co-location company, what their service level agreement is, what's their ability to transfer loads. And again, this all, at the end of the day, boils down to a TCO model as to what's the best cost structure of how to do this. And that's what we're seeing a lot more data center projects employing and looking at, and really trying to control costs and making sure that the data center is competitive in year 5 and year 8 and year 10.
Yeah. And just to add to that, and this is, and actually we're members of a Green Grid Task Force tackling this right now, but this has to do with the intersection of the utility infrastructure, the utility power system, the grid system, in terms of reliability of that power infrastructure, and is it good enough for data centers and cloud compute? And historically, the answer has been no, that the utility grid, because of uncontrolled interruptions that are hard to predict, data centers requiring ultimate reliability can never go down. we're seeing a revisit of that assumption. And to Harry's point, there may be some applications because of it could be a search engine or social media where maybe a latency transfer from one data center to another could be handled. There are other applications where that's not the case, and so there's going to be a great intersection between the application that the end user is experiencing, the data center infrastructure required to serve that, and then what does the utility power quality look like, and those have to be integrated into a system solution so that the right system is offered for that application, and it will vary with data centers.
That sounded like an excellent Green Grid answer right there. I loved it. Guys, we're getting a few more questions here, but unfortunately we have time for one more, and this is always one of my favorites to ask. And again, to the audience, if you are wanting to ask some more questions, by all means, go ahead and put those into the Q&A section. If we don't get to them today, we will be emailing those out to the team here at GE, and they will be tackling those shortly and by email as well. So on to the last question, and again, one of my favorites. This is for both Brad and Harry. Can you give the audience and all the listeners 3 best practices or even predictions around power control, efficiency, a future TCO model, and really what's next for the next generation data center?
Yeah, I'll go first and then let Harry kind of wrap it up for us. But first of all, I do think that on the TCO side, in terms of efficiency, there's been a great deal of visibility to this. And I think there's a good understanding of efficiency matters, PUE metrics are out there. And the next step really is to convert that technical understanding into a business model, and that is the TCO, how to use the total cost of ownership model in these decisions and thought process. And I think we're starting to see a trend to go more and more in that direction. And as this data center industry matures, we're going to see more and more of that. And I think related to this is the next topic we spend a lot of time on. It is the defining of the system reliability required for the data center. What level of reliability is really required? What system architecture infrastructure is needed to deliver that level? And that's where I think we're going to start to see some segregation in terms of how data centers are architected and built to balance the defined level of reliability needed to the total cost, both initial cost and operating cost, to operate that infrastructure.
Yeah, Brad, I agree with all 3 of those points. I'm going to expound a little bit more on the reliability. We're seeing several data center operators. In fact, one did a presentation at a recent data center convention, which really was eye-opening, where they actually evaluated the reliability of 3 of their different locations, which had different infrastructures, to try to correlate reliability and dollars and where do they get the best bang for the buck. And we're seeing this as a trend where people are not necessarily saying, okay, I need super reliability, let's go with system plus system and it costs whatever it costs. They're saying, let's do a reliability analysis. And the IEEE standard 3006.7 gives you the ways to do that. There are 3 ways that you can evaluate the reliability of a particular system. One is a fault tree analysis, one's a reliability block diagram, and the other way is to look at all the different failure modes and do a failure mode analysis and look at the probability of each one of those failures. And so there are 3 methods in there to evaluate one design versus another. So in addition to the TCO model, we're seeing people saying, okay, let's look at the TCO, but let's also look at the reliability of this particular design. And it's going to be interesting to see where the industry goes there. I think the other thing that's really going to be a trend is efficiency is definitely going to still be in the forefront. What can we do to make systems more efficient? I think some of that will move away from the infrastructure. We've done a lot of work to try to make UPSs more efficient, distribution systems more efficient. There's been a lot of work on the cooling side with the free air cooling. But I think you'll see some trends on, okay, what can we do to get better utilization of our IT equipment? What can we do to get rid of comatose servers? What can we do to make sure our software is very efficient running on those servers? So I think there are a lot of things that are going to be happening along those lines as well.
Excellent point, and that's a really good way to kind of round off the conversation here. This powerful combination of logical and physical systems all working in unison. There's really no doubt that just how much data we're producing and consuming is going to impact how the modern data center works, powers, and cools the entire infrastructure. And with that in mind, guys, I'm afraid that's actually all the time we have. We've got a lot of questions coming in. We'll try to answer some of those a little bit later. Definitely a big thank you to all the attendees for making time today and for all of your great questions. If you have any follow-up questions, by all means, go ahead and see the GE Critical Power contact info slide that's up right now to chat with your local data center professional. Just as a side note, the presentation and, of course, the slides will be available on demand from datacenterknowledge.com. So if you want to see this presentation again and hear the conversation, by all means, you can go to datacenterknowledge.com and locate this webinar and download it for your viewing later. Thank you to Brad and Harry for your time, and special thanks to GE Critical Power and all of your colleagues for sponsoring this great webinar. And once again, on behalf of Data Center Knowledge, I'm Bill Clayman. Thanks, everyone, and have a great day.